Good morning, grade 9s, and welcome to Unit 3. Congratulations on making it through Unit 2. I've had some comments, and I think Ms. Shindelka and I have said it before that we thought Unit 2 was significantly easier than Unit 1, and judging from what we saw in the quizzes, and hopefully from the exam, you agree with us as well. In any case, on to Unit 3. Unit 3 is going to be all about rational numbers and integers, and if you don't know what those are, that's fine. That's what we're here to learn. So we'll start with 3.1. What is a rational number? Okay, we're going to be working with number lines a lot in this unit. So it's actually not a bad idea if you just print a number line off and have it next to your computer or tablet or whatever you're learning on. And it's handy to be able to reference a number line on a piece of paper and just kind of trace things with your fingers. I find that students tend to make fewer mistakes when they've got an actual number line right in front of them. So I'll find some on the internet and I'll post them in Unit 3.1. So there's something there that you can print off if you want. Okay, so we extend a number line to the left of 0 to show negative integers, and this is a concept that hopefully you remember from elementary school. Anything on the left is going to be a negative number, and anything on the right is going to be a positive number. Now, you may be used to just seeing integers on your number line. That is just whole numbers, like 1, 2, -1, -2. But we can also put fractions on a number line as well. So if we look at what we've got there, we can represent negative fractions and positive fractions. If this is unit or 0 here and this is -1, well, between 0 and 1, there's a whole bunch of decimals and fractions that we can put on there. So in this case, we're putting fractions on. This would be -1/4, this would be -1/2, this would be -3/4, which is 3/4, and this would be -1, which, if we wanted to represent it as a fraction, we could represent it in multiple ways, including -4/4. -4/4 would just be -1. And the same thing goes in the positive direction. Number lines go on forever, so typically we would see that on number lines as well. So for every a positive fraction, there's a corresponding negative fraction. So we know that positive numbers and negative numbers are essentially opposites. Just like addition is opposite of subtraction, multiplication is opposite of division, and that sort of thing. We call them opposites or inverse operations is another way you might see that. So maybe I'll write that down here. Inverse operations. Okay, so that would be like positive and negative, or plus and minus, adding and subtracting. And multiplication and division are also inverse operations. Those are the ones that we're mostly going to worry about in grade 9. Any fraction can be written as a decimal and vice versa. So for the same numbers up here as fractions, we've got them written as decimals down here. So again, 0 to -1, that's -0.25. This would be -0.5. This is -0.75, and this is -1. So the same thing goes on the positives. So we can write our fractions as decimals, we can write our decimals as fractions, and that's actually going to be important for you in your math career to be able to take numbers from decimals to fractions and from fractions to decimal. And there's more work on that in grade 10, but hopefully you've seen some of that in elementary school as well. But here's the big point of 3.1. Any number that can be written as a fraction with an integer numerator and a non-integer or non-zero integer denominator is what we call a rational number. And most of the numbers that you deal with in your math career are going to be rational numbers. All right, now let's just go through this definition just to make sure we understand. Any number that can be written as a fraction. Okay, well, a fraction, obviously, we've seen before. So with an integer numerator, well, I think we can agree that 2 is an integer, right? An integer is just something without decimals, right? No fractions, no decimals, just a whole number. So that would be an integer numerator. Now don't forget that the top is the numerator, okay, and a non-zero integer denominator. So I'm just going to put 3 down there. That's a non-zero integer denominator. Okay, remember the bottom number is the denominator. You've probably heard me use that term before in some of my videos, so that's just a reminder. When I say top, I mean numerator. When I say bottom, I mean denominator. That's a rational number, and this can be negative or positive. It doesn't matter, but as long as you can write it as a fraction with an integer, so a whole number on the top and on the bottom, okay, that is a rational number. Okay, now this also includes decimals that repeat and decimals that terminate. So if we look at this number line here, There's fractions on the top one, and there's decimals on the bottom. These are all rational numbers. -1's a rational number. -3.2 is a rational number. -3.2 is really just -1.5. If you were to divide -3, divide by -3 divide by 2 on your calculator, you're going to get -1.5. That is a fraction that terminates. So, okay, so if the 1.5 terminates, and it terminates in the 5, right? There's nothing after the 5. That's why it says it terminates. Terminates just means it stops. On the other hand, there are also fractions and decimals that do not terminate. So those are repeating decimals. And if you try to divide -7 by 3 on your calculator, you'll notice that you're going to get -2.3333333. That's never going to end. So that's what's called a repeating decimal. Eventually your calculator just runs out of space, right? I'll just put the dots to say that continues. And when we're writing that, because we're not just going to write an infinite number of 3's here. When you write that decimal that terminates, you just put a line over the part that terminates. Or, sorry, that repeats, not terminates, repeats. So in this case, the 3's are repeating, so there's a line that goes over the 3. So those are both considered rational numbers. So that covers a lot of ground. That covers all the integers. That covers the vast, it covers all the, fractions. It covers most of, I shouldn't say all the fractions, the vast majority of fractions. It covers all repeating decimals and all terminating decimals. So, well, that's the vast majority of numbers that we ever deal with in math. Moving on to the next page, mixed numbers are rational. Okay? Mixed numbers are rational. And what that means is that if you've got a fraction, a mixed number, don't forget, is a, let's just use the example they've got right there, 3 1/4. That's a mixed number. It's mixed because it's got an integer and it's got a fraction. So if you ever see a number that's got, the big integer number, and then it's got a fraction behind it, that is called a mixed number. They're always rational as well, because you can always turn a mixed number into a fraction. So in this case, if we look at, if we look at this 3 1/4, what you do is you multiply the denominator, 4, times the integer, 3, and then you add the numerator, and then it's all over whatever the original denominator was. So to represent this, sometimes I do this, and it's kind of weird because you work you work clockwise on these instead of some people get confused and they try to work this way on them. No, you actually got to start at the denominator. So it's 4 times 3, and then plus that number. Okay. So if we look at this, the final answer, it's over here as well. 4 times 3 is 12, plus 1 is 13, but you're not done. You always have to write it over the original denominator. So 13 over 4, okay, is the exact same as 3 1/4, okay? They just look different. And you're going to see that with a lot of math. And you can do it with negative numbers as well. It works out the exact same way. It's just a negative number instead, okay? So if we look at the number line, all we did here was we put those numbers on the number line. There's your 0 right in the middle, and obviously the -3, well, you got to jump -1, -2, -3, and then an additional quarter unit, so there it is. Same thing on the positive. Okay, so integers are rational. Like I said, any integer is rational. You can represent it. You can represent any integer as a fraction with a non-zero denominator. So it doesn't matter what your integer is. If your integer is -3, it can be -3 over 1. If your integer is 54, you can represent that as 54 over 1. And that meets our definition, right? We've got an integer up here, no decimals, no fractions up top there, and we've got a non-zero integer on the bottom. You can't have a 0 on the bottom of any fraction. It's what we call in math undefined. If you ever see a 0 down here, okay, the whole question is basically undefined. And if you try to do it on your calculator, you'll probably get some weird error. So I'll just try it here. 5 divided by 0 on my calculator, and it says math error. And your calculator will probably tell you the same as that. So if you're ever getting zeros down here, then something's wrong. Go back and check your question. All of these numbers are rational numbers. Okay, they all fit our definition. If it's a fraction, we just need a regular integer up top and a regular integer that's not a zero down bottom. Well, that fits. This decimal terminates, right? So that's okay. It's a 0.5 rational number. Negative 1.8, that decimal terminates. So it's an integer. 0 is always rational. Negative 5 is just an integer, rational. Same thing, you know, all of these fit our definition. This one's repeating, right? So that would be negative 3.333333, but we just write the little line there to tell us that it's repeating. And 1 over 3/4 would be a mixed number. So, if, you know, we kind of look at this and just try to separate these out. Mixed number would be this one, right? Let's see, repeating decimal would be this one. You know, fraction, this one, terminating decimal, would be this one, and also this one, and just a regular integer is, you know, the -5, the 0, the 2, and so on. So just make sure you understand these terms and what they mean, because you're going to see them a lot in this unit. Next, what is a rational number? Well, this is just basically asking us to rewrite the definition that we looked at before. So any number that can be written as a fraction with an integer as the numerator and a non-zero, so it can't be a zero, integer in the denominator. So I don't know if that's word for word from the other page, but we need to know that definition. If you can write it as a fraction with a whole number, an integer on the top, the numerator, and another integer on the bottom in the denominator that is not zero, then that's going to be a rational number. And again, that's most of the numbers in the world. Excuse me. Not all numbers can be written as fractions. So let's look at pi. We've used pi lots. Now we usually write pi as 3.14, but that's not the actual. That's not the actual whole story on pi. Pi never ends and it never repeats. So we've had computers that have calculated the value of pi to millions of digits, but it never repeats at any point, and it never ends. So really, 3.14159, I believe, and then it goes on forever, but it never repeats. Okay, never terminates, so it never ends, and it never repeats. So we can't write these numbers, and root 2 is the same thing. We can't write these numbers as a fraction with an integer as the numerator because, well, it's a decimal and it never repeats. So we can never write this as a fraction the way we need to make it a rational number. Therefore, we just call these irrational numbers. And there aren't many of them, okay? There aren't many irrational numbers. By and large, we're going to be dealing with rational numbers. But you need to be aware that there are numbers that have decimals that never repeat and also never terminate. So here's some example. We're going to write 3 rational numbers between each pair of numbers. And I'm just going to write a number line here. You don't necessarily have to do this if you can do it in your head. But it always helps me to sort of represent where things are on a number line. So we've got 1.25 and negative 3.26. So let's just say that's negative 4, and then I've got to separate it out here. Let's 1, 2, not perfect, but 1, 2, 3, 4, 1, 2, 3, 4. Okay, so let's look at this number line, and there's negative 4, and there's positive 4. So where would 1.2 be? I mean, this is 1, 2, 3, 4. Well, I already wrote the 4, but you get the idea. Negative 1, negative 2, negative 3, and that's negative 4. So we need to write 3 numbers between these two here, okay? So 1.25 would be right about there on the number line. Okay, and negative 3.26 would be somewhere in this neighborhood right here. So I've got to find three numbers that are in this section of the number line. And it's pretty easy to see there's ton. There's actually an infinite number of numbers between those two. So it can be any decimal, it can be any fraction, it can be any whole number. So if I want to write three of those, okay, I could literally write 1.24. Okay, because 1.24 would be just to the left of this, okay? And again, it's infinite. You could do 0, because 0 is in between those two. And then negative 3.26 is here, so negative 2 is in the middle. So maybe I'll write negative 2. Heck, I'll even put negative 2.3 repeating. Still a rational number, and still between those two numbers. So there's many wrong answers on this one, but there's also an infinite number of right answers on this one. So, you put whatever you want. Now, this one here, look at how close that is. It doesn't really matter. There's still an infinite number of rational numbers between the two. So if this is 0, okay, let's just say that this is 0.5, negative 0.5, right? And this is positive 0.5. Well, half of between 0 and negative 0.5, exactly halfway, would be 0.25. And then 0.26 might be right here. Okay, it's pretty close. Sorry, that's a negative and a negative. It's pretty close together, but there's still an infinite number of rational numbers between those two. And we would probably get to those just by writing more decimals. So we have to get a bit more negative than negative 0.25. So let's just write negative 0.25. And if we write 1, that's just a little bit more negative than negative 0.25. So it would just be right next to this line right there. Okay, and then if I want to write 2 more, that's pretty easy at this point, right? Negative 0.252. Okay, negative 0.253. And if you wanted, you could keep putting more decimals on and get smaller and smaller and smaller, but you'd still have numbers that fit between negative 0.25 and negative 0.26. So all of these numbers here fit in that little space right there. Now we've got fractions, so let's just make another number line and let's look at some fractions. Put 0 in the middle. We've got half and a quarter, so let's just put negative 1 here and positive 1 here. And then let's look at our fractions. Negative 1/2 would be right there, halfway between 0 and negative 1. Okay, and 1/4. Okay, so if this is the halfway point, so this would be positive 1/2. 1/4 would be halfway between 0 and a half. So what we're looking at is numbers between negative 1/2 and negative 1/4. So we need to find a number between, or fractions between there and there. Now you could write decimals, but because it gave us fractions, let's just look at some fractions that would be in between this. So what sort of fractions would be between a quarter and negative 1/2? Okay, now it doesn't say you have to use fractions, but we're just going to use fractions. Okay, so let's look at what possible fractions we could have. 1/8, okay, 1/8 would be right there. Okay, so 1/8 is halfway between 0 and 1/4. So 1/8 would be a rational number between this one and this one. We could also go to the negative side. This would be negative 1/4 right there. So that's one. Negative 1/4 is another rational number that fits between these two. And is there a number that is between negative 1/4 and negative 1/2? Well, yeah, negative 1/3. Negative 1/3 would be about right here. Okay, so negative 1/3 would be there as well. And you can go further and further and further with your denominators to put more numbers in there. 1/80, for instance. 1/80 would be just next to the 0 here. Negative 1/80 would be to the 0 here. So you can put extra numbers behind your denominator and your fraction, and that might make it easier. Just make sure. I think it's important that you draw some number lines as you're getting used to these, so that you can kind of physically and visually represent it's got to be between here and here. So what do I know that fits in between the two? Takes a little practice, and I think you'll be better at it with decimals than you will at fractions. Students tend to be better with decimals than fractions, but we do need to practice our fractions. They're very important in grade 10. Use a number line. Now we have to order these numbers. Now the decimals tend to be easier than the fractions, so I'm just going to draw a line. I'm actually going to use the line tool this time because that might make it a little easier on me. So let's just draw a line. Okay, this is a number line that continues forever, so put a little arrow on each end. And we've got negative numbers and positive numbers, so usually when that's the case, I usually put the 0 right in the middle. We've got all sorts of decimals. Nothing is higher than 2.5. Nothing is lower than negative 3.2. So I'm going to make this negative 4. You always just want to make your number line big enough. You want to make your number line big enough that it fits all of the numbers. So never put negative 3.2 right on the end. You always want to go to a whole number. No decimals, no fractions. It'll make your life a lot easier. So if that's 4, halfway there is negative 2, and halfway here is positive 2. And now let's just start looking at what these numbers are. 0.35. Okay, 0.35 is about a third of the way. Just put in a few more here. Okay, is about a third of the way between 0 and 1, right? So it is somewhere in this range here, all right? So if it's 0.5, it would be right here, right in the halfway point, but it's a little less than that. So I would put this right there, and if you need more space, you can just go up here. So that would be 0.35. So I got that one taken care of. 2.5 is pretty easy. So that's 2, and that's halfway between the 2 and the 3, well, give or take. And so that would be 2.5. Okay, let's look at the next one, negative 0.6. Okay, so here's negative 1. So it has to be between 0 and negative 1. And it's not half, because half would be negative 0.5. It's a bit more negative. So I'm just going to put it just a bit closer to the negative 1. And that would be negative 0.6. Next number is 1.7. Well, that one's pretty easy. Let's find the 1. Well, this would be 1.5. So 1.7 is going to be just a bit further towards the 2. There's 1.7. Negative 3.2. Okay, so let's find the negative 3. Okay, halfway would be negative 3.5, so negative 3.2 is going to be right about there. And then the last one is negative 0.6 repeating. You don't have to worry too much about the the repeating decimal. If we wanted to round it, that would round to negative 0.7. Okay, because it would be 666s all the way, so we would round that to negative 0.7 if we were rounding to a tenth. But what we know that is more than negative 0.6, but just barely. So it's pretty tight here, but I'm just going to try and squeeze another line in there, and that would negative 0.6 repeating. So it would, if this number line's to scale, negative 0.6 repeating is going to be pretty much in almost the exact same place as negative 0.6. But so there we go. We've ordered those numbers from greatest to least on a number line, and then if you wanted to write them out below in order from least to greatest, let's just make a little box down here and let's just write them from least to greatest, because often a question will ask you to do that. You use the number line to figure it out, and then you write down all the numbers down here. So which is the least number that we've got here? It's the negative 3.2. That's the smallest number we have. What's next along the line that we drew? Not including those numbers that we just put in as markers. The next one is the negative 0.6 repeating. Then the negative 0.6 is right next to it. Then our next number that we needed to draw on it was 0.35. The next number was 1.7. And the last number was 2.5. So there we go. We used a number line, and that made it a lot easier for us to write the numbers from the lowest to the highest. That would have been, maybe you could have done it just by looking at the numbers. If you're good enough with decimals, that's fine. But if it specifically asks you to use a number line, make sure you do this process first. All right, now fractions, a little bit tougher for students, but you're going to get lots of practice with them. So let's draw our number line. I'll try and draw it as big as I can so I didn't run out of space. So here's our number line. And let's put our 0 in the middle again. 0. And what's the biggest number we have? Okay, that's going to be 2 and a bit. That's 1 1/4. And 3/8. Okay, so if I go to, that's going to be, if I go to -3 on these, or +3 and -3, that should be enough room. So there's -3, there's +3. Now exactly halfway, okay, exactly halfway between 0 and -3 is -1.5. So that would be -1 and then a half. That's a mixed number, right? Big number out front, then a fraction. And the same thing over here, except it's going to be positive. So this is going to be +1.5. Still a fraction, okay? It's a mixed number, but if I wanted to write this a different way, okay, this is also the exact same thing as 2 times -1 is 2, plus the number 1 is 3. So that's the exact same thing as -3/2. And this is the exact same thing as 3/2. Okay, 1.5 is the exact same thing as 3/2. So we have to order these from greatest to least this time. So make sure I read the question. Record the numbers on a number line. All right, so let's look. -3/8. -3/8. Okay, so that's less than 1, because 1 would be 8, -1 rather. -1 would be -8/8, so we know it's less than that. Okay, if we were to put 1 on this number line, 0, 1, 2, 3. Okay, so I'm just gonna kind of roughly sketch those out. That probably wasn't a great job of roughly sketching those out, but I wanted to have some fractions in there. If this is -1.5, okay, let's say that this is 1 right there, okay, or -1 rather. It's less than that. It's also less than half, right? Because half, or -half would be -4/8. Okay, so it's somewhere in between here, but slightly less than the halfway point. So I would put this as -3/8. It's pretty close. So we got that one done. 5/9 is a positive number. Okay, 5/9, okay, is slightly more than a half. Okay, because half of 9 would be 4.5, and this is 5, so it's slightly more than a half. If this is -1.5, if this is +1.5, let's just say that this right here is 1. So this would be the halfway point, okay, and it's just a little bit more than the halfway point. So if I'm looking at 5/9, I'm probably looking at something right there. Okay. -10/4. Okay, so -10/4. I'm just going to pull it over here for a second. -10/4. Okay, you got to ask yourselves, how many times can 4 fit into 10? It fits in 2 times, except in this case it's negative. Okay, so 2 times 4 is 8. What would be left over between 10 and 8? Okay, it would be 2/4. And we can simplify this even further, so it would be -2, and we know that 2 out of 4 is just a half. So we're looking at -2.5 here. All right, so let's go. This is -1, this is -1.5. -2 would be somewhere in here. Let's just call that -2 right there. And then -2.5 is going to be right between those two. So that right there would be -10/4, which is the same thing as -2.5. All right, that takes care of that one. -1 and 1/4, I believe that is. Well, here's -1. Here's -1.5. So halfway, a quarter. You got to think about it this way. If this this is half, think about it as dollars. If this was half a dollar, it'd be 50 cents. And if this is 50 cents, and we go from here to here, then halfway would be a quarter, right? A quarter is half of 50 cents. So sometimes it helps me to think about it as numbers. But anyway, if this is -1, and then this is another half on top of that, we just split it into a quarter. And this would be -1 and 1/4. So it takes care of that one. 7/10. If you got 7 out of 10 on an exam, you got 70%. Okay? It's not 1. If it was 1, it would be 10 out of 10. Okay? So 10 out of 10 is right here. Right? That would be 10 out of 10. Okay? 7 out of 10, well, this is 0.5, right? So it's between 0.5, or in this case, 1/2, okay, because we're using fractions, it's between a half and a 1, and it's just a, it's just a bit less than halfway between here, because halfway between a half and 1 is going to be 3/4. And 3/4 is 75%, right? But this is only 70%, so it's just a little bit less than halfway between a half and a 1. So if that's halfway, it'd be right there, would be 7/10. And then 8/3, I'll work with 8/3 over here. 8/3 as a mixed number, okay, how many times does 3 fit into 8? It fits in 2 times, okay? And then what's left over? Well, if we divide 8 by 3, right, we can get it 2 times it goes. 3 will go in 2 times per, sorry, 3 will go in 2 times. Okay, we can fit 2 3s into 8. Well, 2 3s is 6, right? So what's the difference between 8 and 6? Okay, that would be what was left over. It's remainder. You've done this in grade 3, 4. You just maybe not used to seeing it as fractions. So it fits in 2 times, and then there's 2 left over, and then you always got to keep the base there. So it's really 2 2/3, or 2 2/3. Well, this is 1.5. This is 1. So let's just say that this is 2 here. Okay, so it's past 2. It's greater than 2. It's 2 2/3. So if this is between 2 and 3, that would be 2.5, right? 2.5. And 2/3 is more than a half, so it's going to be somewhere right about there. So that's 2 2/3. Number line's getting a little bit messy here. There's just too many things to put in there. Now at the end, it's very easy for us to just look along our number line, and we're going from greatest to least this time, so we're going to be starting here and going the other way because we want to start with the big numbers. So 2 2/3 was our biggest number, and that was actually 8/3 is what they gave us, so I'll just write that 8/3. So our biggest number was 2 2/3, or 8/3, so we're going to write 8/3 is the greatest number. And what's the next one we hit? It is, I believe, 3/2. Is that the next? Oh no, we wrote that as 1.5. The next number is this one. That's 7/10. 7/10 is our next number. And then very close to 7/10 was 5/9. And then keep going backwards here. Was -3/8 one of our numbers? Sure it was. -3/8. And then -3/8. Let's keep going back. Was -1 1/4 one of our numbers? Sure it was. So that's -1 1/4. Make sure you write the big number out front so it's obvious that it's a mixed number. And when we keep going this way? Is -10/4 our last number? That would be our least number because it's the biggest negative. I'm just going to count to see if I got them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I think I got them. So this would be from the greatest number to the least number. So that's 3.1. Have a try at the practice questions in the text. The answer key for the textbook is both at the back of your digital textbook, and also I've posted it in Unit 1. I probably post it again in Unit 3 so that you have the answer key for the book. You need to use your digital textbook from this point forward. I sent everybody instructions on how to access the digital textbooks, and anybody who had emailed me, I had helped them through the process. So make sure you can access your digital textbooks because due to copyright, we have to use the licenses that we were given on that website. As always, send us an email if there's a certain question that's giving you trouble. Try to be as specific as you can, and we are going to do our best to help you out like we always do. All right, good luck.